I'll just give it a couple more minutes to allow more people to join, and then we'll make a start.
Hello, good evening.
Okay, I'm going to make a start. I'll ask everybody to mute themselves, and
Okay,
we'll make a start. Okay, so welcome to this first workshop. This is the preparation for the StarkNet Winter Hackathon. Let me share my screen. Okay, I think you can see that okay. And also let me put into chat. If I can get to it. We have a link to these notes. So if you want to see, there we go. All right. And I'll make a start. Okay, so yeah, welcome. Notes are available there. This is the first of 3 workshops. Um, the uh, the plan we have so for today was very much an introduction. It's very much about preparation, making sure that people have things set up and that you have a basic understanding. I have been led to believe that people will have some knowledge of Rust and Cairo. If that's not the case, then please let me know. But that's where I'm starting from. Um, so today what we're going to do is I'll start off giving some general advice about hackathons. So I think this is going to be useful when you're thinking of how to approach the upcoming hackathon. Then we'll have a review of StarkNet and its ecosystem. We'll look at the development tools and how to get those set up. And then we'll go through reviewing Cairo language and Cairo contracts. So I'm assuming, again, so that some of this you will already know. But yeah, do let me know if not. And then on the next workshop, we'll go into more details about the language, and we'll particularly look at issues around testing and how you can do that. And then in the final workshop, we'll look at some more practicalities of development, looking at things like common patterns that will be useful, things like account abstraction. We'll look at some specific areas such as DeFi and game development. Okay. So that's the plan. Now, what we have set up is we're using Slido for Q&A. So if you have any questions, I ask you to use that. I'll put you the link into chat. There we go. Okay. So yeah, so today's topics, I'm going to start off with some hints about hackathons. We'll then have a look at the StarkNet ecosystem. We'll look at development tools, and then we'll talk about the Cairo language and contracts. Now, there's a link there to Slido, so please ask questions there. It's difficult for me to see Zoom chat um, most of the time, so your questions may get ignored if you put your questions there. There's also a poll I've put in to Slido because these are the different tracks that are available on the hackathon. And so I can go into more detail about some of these areas if people are interested in those. So let me know. I can see some people have already started to fill that in. So yeah, if you let me know which ones you're interested in, And then perhaps in the last session, we could concentrate on one of those in a little bit more detail and look at some practicalities of interacting with it or using it in some way. Okay. All right. So just a little bit about my company, Extropy. We're a consultancy based in Oxford. We've been doing workshops for a long time. There's some pictures here, some photos from some of our workshops that we did in person before COVID came along. Something we very much enjoy. We also do development and auditing. Um, but yeah, a lot of our time is our focus is on workshops. There's some details about how to get in touch with us. Please join our Discord server. You can contact us on social media or email us. That's all good. All right. So let's talk about the hackathon. So these are the details. These links. Let me just check these. These are the details of the hackathon we're all uh, aiming for. So you need to make sure you've got this bookmarked. Um, Particularly, the timeline is something to be aware of. So, this is where we are at the moment. So, we're doing the first workshop. We're going to do two more of those this week. Um, you're going to have some more input from Starkware about Cairo. The onboarding task, what this is I'll present a task for you to complete at the end of the third workshop. It will be a simple task. I think it's probably going to be to ask you to write a contract that will then interact with the contract that I have deployed, something like that. So it's just to make sure that you've been understanding what we've been going through. It's just really for you to check, check where you've been, how far you've got. Um, the question on Slido, are we going to get this recorded sessions? I believe so. I'm not the one recording it, but I believe it is being recorded and streamed. So I believe so. Okay. All right. So that's that. And then at the end of the month, you will have that'll be when you're starting to form your teams. And then the hackathon itself will open. So we're very much at a preparatory stage at the moment. It's very much getting you ready so that you can make the most of the hackathon. Okay. Now, in terms of prizes, it's when you're thinking about a hackathon and how to approach it, obviously you're going to be thinking about the prizes that are available. Now, okay, there are perhaps two ways to look at this. So maybe you'll be wanting to aim for a prize. Of course, you don't have to do that. You can still partake in hackathons without aiming for a prize if it's just that you want the fun of participation, or maybe you've got a particular project you want to try out and you want to get other people involved with. But it's worthwhile thinking this through before you start, because it will change the approach that you take to the hackathon. So it's worthwhile having a think about this. So we've got prizes. This is the pretty typical, I think. So we've got prizes from Starkware, so general prizes, and then we have a number of tracks where we have individual companies or projects that are asking you to do something with using their existing project. And so when you're approaching the hackathon, you really have to have a think about how you want to do this. Are you going to aim for just a general prize, or are you going to aim for one of the tracks? And one part of that, I think one thing that is useful to think about is that not all of the tracks will be equally popular. And so you will certainly have a better chance of winning a prize if you're in a less popular track. So it's worthwhile being aware of how popular each track is and what other people are doing within those tracks. So all of that information can be quite useful if if you're interested in getting a prize. I should also say that the um, even if you don't get a prize, don't think that's the end of the story. Very often, months after the end of a hackathon, you will get contacted by people who have seen your submission for the hackathon, who've seen your project and are interested in it, or maybe they want to help you develop it further. So whatever you do, I think as long as you get something that is you can get a demo going, then it is valuable experience and it may lead to something, even if you don't get a prize. The question on Slido about knowledge of Rust. Um, yeah, it really does help if you do have knowledge of Rust before learning Cairo. I mean, Rust is a very useful language to learn generally. The Rust syntax is being used in a number of uh, DSLs that are being used by zero knowledge proof frameworks. So it's a very useful language to have some knowledge of, at least some basic knowledge of, because you can then apply that and it gives you a good starting point for a number of different languages. And certainly Cairo is very much the syntax and some of the ideas are very much based on Rust. So I would advise that you get a little bit of understanding of it. And if people want some more details about Rust, I can give you some resources about that. There are some good exercises that you can do that will help teach you Rust, and there's some good resources. So I'll put an answer into Slido about that and give you some links to those. But it's worthwhile spending a little bit of time on that, ready for learning Cairo. Okay, so yeah, I put in the poll, so there's the link to it. Thank you for filling that in. So it looks like people are particularly interested in the Jedi Swap, Argent and Pragma at the moment. Yeah, all good, interesting projects. Okay, so let's talk generally about hackathon tips because, as I say, this workshop is very much about preparing you for the hackathon, and so I want to share my experience. So I've participated in a few hackathons. I've also, uh, excuse me, been a judge in a number of hackathons. And so I've got quite a lot of experience and seen lots of projects and the way that hackathons have worked generally. So I want to share some of that experience with you to make sure that you get the most out of it. So the first set of tips here, actually, I should say as well, if you go to our Medium site, if you go to Medium and look for Extropy, we do have a much longer article about hackathon tips. I forgot to link to it here, but we have got a much longer article. So it's worthwhile having a look at that also. But yeah, anyway, so general tips about hackathons. Um, Time is generally your enemy. I mean, particularly if it's just a weekend hackathon, but even when it's a longer hackathon, you generally don't have as much time as you would like. So you do need to think about that and think about some that you're think that you're going to have to make some shortcuts and think about what you're going to prioritize and what trade-offs you might need to make. So be ready for that. And yeah, emphasize getting something finished really above most other things, I would say. Now, to help you do that, you're going to need to work efficiently as a team. So if this was a weekend hackathon, I would say don't all take breaks at the same time. For a longer term hackathon, it really just means making sure you're available when you need to be available, and that the people in your team are going to be around and going to be able to work together as you need to, and that you've worked out some mechanism to do that. You have a way of meeting up and organizing your time. The most important thing about the hackathon is the submission, so be prepared for that. Make sure you know exactly what you need to do and don't leave that to the last minute. Because what is usually the case with a hackathon, you need to get a demo going, you need to have some sort of presentation and make a video. These things take time. They take time to set up and organize. So get as much of that done beforehand as you can. If you leave to last minute, you won't make as good a job of it. So really, yeah, get that out the way if you can. And remember that, even you could make a fantastic project, but if you haven't got that in your submission, if you're late with your submission, then the world won't know about that. So make sure you're completely prepared for the submission. Within your team, make sure you have a common setup and tool chain. You don't want to be spending time translating between or organizing different tools between the different people in your project. So choose a particular tool chain or a setup and then stick to that. Even if you think it's not the best one, it's better to have something in common rather than having people working on different things. It's going to introduce friction into your work. Um, when you have to do the demo, make sure that this can run on multiple machines because it's just going to be, bad luck that if you've only got it on one machine and then for whatever reason it doesn't work at the time you want it to, or that machine is not available. So make sure you have some backup capability there. Uh, it's useful to, before you start the hackathon, to get details of the ecosystem sorted out and get links for anything you need, such as RPC nodes or faucets. Get those into a shared document so that you're not hunting around for these time and time again. So it's just, yeah, again, it's going to save you time in the long run. So get all of that information into a shared document along with, things like the hackathon details as well. And then a very important point, I think, is that you will have sponsors and mentors available to you, and it really does um, make sense to get as much help from them as you possibly can. Now, this is not only getting technical help. I mean, obviously that will help you, but also these are the people who are going to be judging your project. So, getting them introduced to what you are doing and giving them an idea of the progress you are making and getting their opinions and their advice and showing that you are following their advice when you're uh, creating your project will impress them. It will make an impact with them. So it's really going to help the final results if you work as closely with the sponsors or the mentors as you possibly can. Okay. So let's move on to the general design of the project. So as I said earlier, you are going to want to you need to think about whether you are going for a particular prize, and obviously which prize you're going to, or if you're going for a particular track, or whether you're not really interested in that and you just want to develop an idea. And again, that's not by itself, it's not a bad choice. And it may be, I've seen people do this in multiple hackathons where they've started development of an idea in one hackathon and then carried it on through a number of hackathons, refining it as they've gone along. So, but you do need to think about that when you start, because it will really alter your focus. Because if you are going to win a prize, you have to be uh, very focused on what you need to do. So, as I said before, if you are going for a particular track, be aware of the competition within that track. So look at what other people are doing and make a judgment based on that about your realistic chances of winning a prize, because it may be that you could pick up quite a prize quite easily from a less popular track that may be more beneficial for you. Of course, it's also possible that sometimes you can enter multiple tracks. It's not always possible, but that can be possible. So do think about that as well. If the project you're doing is using two pieces of technology, then it would make sense for you to be in multiple tracks. Um, if you are choosing a track to go for, you're going to go for a particular prize, then make sure that you meet all of the criteria that are being asked of you. So if a particular project says that you have to build using their framework or their wallet or whatever it is, make sure you are doing that and make it very clear to the people that you are doing that. Don't expect them to hunt around in your code to find out how your project applies to them. Make it very clear up front what you are doing and that you are, that you are focusing on their technology, and that will make the judging easier, and you're liable to make a more favorable impression with them doing that. And also, you need to understand the evaluation criteria. So if they say yes, you have to use this particular technology and you have to do it in this particular way or achieve a particular thing, then make sure you do that and make sure you spell out that you do that when you're making your presentation. Now, this particular hackathon is based on a particular uh, ecosystem. We're developing on StarkNet, but that doesn't mean that you can't take ideas from other chains. And there's quite a lot of people have been very creative in some of the chains and solved challenges in some creative ways. And it does no harm at all to borrow other people's ideas. And so the example I put there, e.g., POH is proof of history from Solana. So this was an innovation that they had, which was quite a neat idea, introducing the idea of a decentralized clock, essentially. And but it is not that difficult to implement. It's not conceptually too complex, and so it's the kind of thing that you could borrow for another chain. I mean, that's just one particular example, but do be aware of the types of problems that have been solved generally in the Web3 space and the type and the way that people have done that, because it could mean that those patterns would be useful for you when you're developing your own project. Okay, so going to more detail now about the particular project you're building. I think one of the major things, a piece of advice I would give is to keep the scope small, because I very often see people being over ambitious when they're building something, and as a result, they don't get very far with it. It's very demotivating because they don't feel they've achieved very much, and the whole project kind of peters out. And particularly with a hackathon, because you have to you really should have a demo of something working. If you can't get that, then you're not going to be winning prizes. So keep the scope small. Uh, you and make sure you get something working. You can then add extra functionality later on. So that is, far better way to go around about it than to go the opposite direction and be too ambitious to begin with. Avoid the temptation to generalize. I know as developers, we often try to make our code flexible in many ways, but people sometimes do that and try to make their code provide a lot of functionality that is not needed. So avoid that temptation. Be very focused on what it is you have to provide for your particular track, your particular prize, and make sure it does that. And don't add extra functionality at that stage if you don't need it. Now, one potential idea that could work is using composability. So you've probably come across this idea in DeFi. I mean, the idea of putting projects together, and it is quite a valuable and a reasonable thing to do for a project, I think, is to take existing projects and then maybe link them together or add something to them with your project to build something new, something innovative. So it's not the case that you have to do everything completely from scratch. It certainly can be valuable to take something that exists and then maybe modify it in some way or add some type of innovation to it or link things together in some way. And that idea could save you a lot of time and help give you quite a functional, quite a large featured project without having to do a lot of work. So to help you with that, I would say it's worth investigating the types of projects that are available within the ecosystem. Also, on that idea, sometimes you can get a good idea by taking something existing and realizing that perhaps there's something that isn't needed in that, and that by removing something from an existing project can actually make it better. And one example of this is it's not particularly to do with Star, or could be to do with, no, not particularly to do with Starknet, but is the idea of off-chain computation and having private input to some computation. And when you do that, then that reduces the amount of security that is needed. And so if you look at existing projects, they will often have all sorts of code and layers built in around security. And if you can think of a way to achieve that without those layers, you may end up being able to do something, quite innovative or quite valuable as a result. And an area that I think is quite is popular, but it's certainly worth looking at is around account abstraction, because been if we've come from an Ethereum background, been working on Ethereum layer one, you will have we are very much fixed in the way that accounts work, in the way that they worked back in 2015. The layer twos that have been developed have had the chance to redesign this, and we have account abstraction, and we have this on StarkNet, and this really opens up many new possibilities and allows a much better UX. So take advantage of that. If you're yeah if you, when you're building on StarkNet, look at what account abstraction can build you. Don't sort of just think in what you've seen, say, on Ethereum, and the kind of apps you've seen there. Think of the improvements that you can get because we have account abstraction. And you can particularly see this in things like games, where you don't want in a game, you don't want to have to be signing a transaction every time you want to make a move in a game. And with account abstraction, you can automate that to some extent, and you can sort of pre-authorize a number of transactions. And this obviously makes the UX much better. Okay. Um, Going further just into the development, I would say because of the time constraints you have, don't worry about optimizing your code. There'll be time to do that later. What you'll really need to focus on is getting the major functionality out. And similarly, unless it's a major problem, don't worry about the gas cost. And unless you start to hit limits, or unless the the cost of using your project is, an essential feature of your project, I wouldn't worry about how much it's going to cost at this point. Get the functionality there first, and then later on you can look at optimizing it. Um, Use the existing development techniques that and things like, test-driven development is good to use. But again, don't go overboard with that. In the same way that you don't want to increase the scope of your project too much, don't increase the scope of your tests over much. Focus your tests on showing that the functionality that you want is working. Now, that is kind of bad advice generally, because that could mean you've got all sorts of security problems. But at the moment, focus on getting the functionality there, and then you can focus on security after the hackathon and when you're sort of building it out further. If there are things that you need that you don't have time to build, then it is perfectly acceptable to mock these things out, as long as you are clear about this and you don't try to pretend that you've built something when in fact you haven't. So if it's if you don't have time to build something and it's going to create a problem, then just mock that part of your system so that the whole thing is, you can demo the whole thing, but make it clear that, you've mocked it, but also show that the way that the thing that you've mocked is feasible. It's, don't say, well, we've mocked, I don't know, a DEX or something that actually would be completely infeasible to build. So whatever you've mocked out, make sure you've thought through what it is actually achieving, or the functionality it provides, and make sure that is actually feasible. And then automate as much as you can. So we'll go through some of the tools in a second, and yeah, you can see how these will help you automate the whole process as well. Now, the next point, this is particularly important, I think, where you're very limited for time. So if you had just a weekend hackathon, but it does apply generally, that it's in development. One of the most important things is to keep up your energy, and at some point, as you're working on your code, you'll find your energy is dropping, and you're starting to get stuck, you're not being as creative with the solving the problems that are coming up as you could be. You're making mistakes, you're flagging. So recognize that this is going to happen. So at that point, take a break, get help from your colleagues, talk things through with them, go and get help from mentors, and also recognize if you're approaching if you've started to solve a problem and everything that you do is just getting worse and worse, and you're kind of digging yourself deeper and deeper into a hole, that may be that may indicate that you have got some fundamental assumption wrong in your design. You may have to sort of step back a little and think about what you're doing and whether you have got, whether you're actually going in the wrong direction, and maybe you have to redesign something. That might not be the case. It may be just that you've made a typo somewhere and it's a simple fix. But either way, just things like taking a break, getting a fresh mind, getting a fresh pair of eyes on it, that will definitely help. So don't grind yourself down getting stuck on something. Just try to do things to keep up your energy. Okay. All right, so there are some useful building blocks and techniques that are going to help you when you're working in Web3. So it's a good idea to understand these things because they come up time and again, and they are useful across many different types of blockchains. So understanding how these things work will be very useful for you, whatever hackathon you're doing. So the first one is or are Merkle trees. These are used so widely. They're really ubiquitous. But they are a very useful way of storing data, storing a fingerprint of data, and being able to check whether that has changed or showing that something is a member of a set. Essentially, Merkle trees are really showing set inclusion, and you can create Merkle proofs to show that something is within a set. So understand how those work. There are improvements on those called Verkle trees, which are coming to Ethereum, which are more efficient. So it may be useful to have a look at those as well, but certainly be aware of Merkle trees. That also means you have to be aware of hash functions, again, used very widely, and you really do need to understand them. And hash functions, and in fact, coming on to the next point, they're a type of commitment scheme. And so they have a couple of properties as such. They have a commitment property, which means that once you have decided on an input to a function, then you are committed to that input. You can't then later change your mind and say, oh no, my input was actually something different. And this relies upon the fact that hash functions are collision resistant. So for a particular input, you will always get a particular output. And if you change that input, you will get a different output. So you need to understand these concepts. And then the idea of commit reveal schemes are very useful, particularly in games. And if you're looking at writing a game in a decentralized environment, then we usually have the problem, particularly if we're in a public blockchain, we have the problem that the other players can see what your moves are. And one way to overcome that, at least to some extent, is via commit reveal schemes, where you obfuscate a particular move or a particular piece of data, but you commit to it. And then later on, you can do a reveal where you reveal your data or your move, and that can be matched against the commitment that you gave earlier on. So again, be aware of how those things work and those patterns work because they could well be useful for you. Understanding signatures is important because these are widely used. Obviously, you're getting you're getting transactions, and these signatures of these will be checked. This comes into account abstraction as well, and so be aware of how signatures work. There may be you may want to handle signatures within your code as well. You may want to be able to verify signatures within your code. So be aware of how that is done. Now, cryptography is obviously it's a complex subject, but there are some aspects of it that are sort of pleasantly surprising. And one of these is the homomorphic properties of certain cryptographic functions, such as hash functions. And what this means is that uh, we can we can do some operations, simple operations such as addition and multiplication on data that has been either encrypted or hashed, and that can provide a meaningful result. Now, the reason this can be useful is that it helps with privacy. You can use this to allow people to get operations done on data that is encrypted, and the people doing the operation don't know what the original data is. So it is a way of preserving privacy. You can outsource some computation to a third party, and the data you sent to that third party could be encrypted, and that third party can do some computation on it, some analysis maybe, send you back the result of that, which is still encrypted, and then you can decrypt that and get back a sensible result. So those types of ideas could well be beneficial for you if you're thinking about something in a project where privacy is important to you. But then I say cryptography can be very useful, but also it has its limitations. One of these around things like zero knowledge proofs are some of the limitations, and we'll see this when we're looking at Starknet. The fact that zero knowledge proofs rely upon certain types of mathematics, and this is a restriction that makes some things difficult to implement, and the fact that we're using integer-based systems. And I'll talk about this later, but it comes in when we're looking at the integration or looking at how we can do machine learning alongside zero knowledge. That is this limitation then starts to show, and that becomes a major problem. So do be aware of those types of things. Whatever you do with crypto, be aware of it, be aware of what you can do, but whatever you do, don't try to what's called roll your own crypto. Don't try and reinvent the wheel. Don't try and create your own hash functions because, well, one is very complex, it's time consuming, and you're likely to get it wrong. It's something that takes a long time, and you have experts doing it. So rely upon the things that already exist out there. Rely upon the cryptographic primitives that are out there and make the most of them. Okay, how are we doing? All right. Okay. So that was some general approaches to, some general tips for hackathons. Just wanted to talk about privacy a little bit because I see this as an area that is increasing in popularity. There's an increased appetite for privacy within projects generally, and it's not something that we've seen very widely in application. I mean, particularly if you think of the Ethereum ecosystem, Ethereum is a public blockchain. All the data is public. There is no privacy. And similarly, excuse me, with Starknet, all of the data on Starknet is public as well. There's no privacy involved there. But it is something that there is an appetite for. So it's useful to get an idea of approaches that you can take to get privacy if this is something that you want in your project. So there are some projects out there that you may want to look at that could help you. So the first two are in some ways similar. So Aztec has just recently really changed or brought out a new direction and way of working. Mina, the way Mina works is has been established for a while, but what they both allow people to do is to do off-chain computation and then have proofs that that has been done correctly. And actually, I mean, this you can see this is possible with Cairo as well, with Cairo programs. Although in Starknet, as I say, in our Starknet contracts, everything is public at the moment. But this idea of off-chain computation does allow privacy because you can allow private inputs to the computation and then just provide some details of a state change and a proof that that is correct and provide that to a public blockchain without giving away all of the details of the private inputs. It can be sometimes enough to do obfuscation rather when you're with privacy. That's not completely secure by any means, but for a particular use case, it may be enough. And for example, if it's a game or something like that, where maybe the results of details leaking are perhaps not that important, or maybe there's a short time in which it is valid anyway, then perhaps it is enough just to obfuscate a particular piece of data, for example, by using a hash function. Yeah, I've just spoken about the idea of off-chain computation. The next point is something that is a general pattern that I think is very useful to keep in mind. This really is the nullifier pattern. This is, excuse me, the approach that was taken by Tornado Cash, for example. It's also used in Zcash, it's used in Aztec, and it's a way of effectively breaking links between accounts. And if you look at it in the way that Tornado Cash works, you have someone depositing into Tornado Cash with one account and then using another account to withdraw funds from Tornado Cash. And there is no recognizable link between those two accounts. So somebody looking at the transactions would not be able to work out which account was being used, or how those two accounts linked together. And the way this is done is via what is called a nullifier pattern. And this is the way it works is that when you the first part of it, when you do say a deposit, what you do is you create a nullifier. This is something that is deterministic, that is created from details of the account and the thing that you are depositing, but it also involves some private information from the person that is doing that. And this nullifier is created and it is effectively obfuscated, but the creation of this, and then this nullifier is added to the state of the system. What this nullifier allows you to do is to show that a certain thing has happened. So, for example, when to avoid double spend or to avoid a person in Tornado Cash from withdrawing their funds twice, what you do is you check for the existence of this nullifier, and the existence of a nullifier shows that a particular action has happened or shows that a particular resource has been consumed. And so it is very applicable. It is useful in very many different circumstances and really lends itself to the idea of helping with privacy. So if you're interested, have a look at that. See how it's done in Tornado Cash and how it's done in, say, Zcash. It's a very useful pattern to understand. Multi-party computation. This is used, particularly people use it in wallets, but it can be used more generally. Multi-party computation involves a number of people working together, collaborating to produce a result from a computation, but each of them provides a private input, and none of the other people in this collaboration get knowledge of that private input, but they are able to achieve an output from the computation of all of their inputs. Similarly, there's a process called Shamir secret sharing. It's a very simple technique. It allows you to split up a secret into a number of pieces that can be shared. So, for example, it can be used if you have a key and you want to break that up into pieces that a number of others can hold. And then you can do things like saying, well, of the holders of all these pieces of this key, say 7 out of 9 of them have to come together to reconstruct the key. So there's all sorts of flexibility around it, but it's a very simple technique to use, a very simple pattern. So if you want more details, then ask me. The final one, Mackie, this is an anti-collusion infrastructure. I won't go into much detail about this. If you were interested, have a look at the Mackie project on Ethereum. But it's a way of preventing people from colluding or from bribing each other. So where you've got something such as maybe you've got a project that is giving away grants, and you're worried that the people who would receive the grants are going to bribe the people who are voting for which which projects will receive a grant. If you're worried about that type of thing, this anti-collusion infrastructure is a way of getting around it. So take a look at that. All right. Another area that is really underdeveloped, I would say, are ZK bridges. So we're seeing increased interoperability in blockchains. We're seeing lots of bridges being built between blockchains, and there's certainly the appetite for that. People want to be able to see liquidity across chains and to be able to transfer assets easily across chains. But typically that you can't do that in a confidential way. What ZK bridges allow you to do is to have some confidentiality involved in that, and it uses zero knowledge proofs for that. So that may be something that will be useful for you. So have a look for some of those projects, and then this one here, ZKML. This is something that you would think. Well, I think it's true that there should be a lot of excitement about because it's bringing together some of the big buzzwords, and certainly at the moment there's a lot of interest in machine learning. So the whole area is there's a lot of appetite, a lot of interest in it. There's a lot of potential there. But it is not simple. And part of that reason I spoke about earlier is that the two areas, zero knowledge and machine learning, don't easily fit together because of the underlying mathematics. But luckily, we've got some very clever people who have gone in and started to work on this and are starting to make progress. And one of the tracks I think is from Giza. So this is a way of doing this on StarkNet. This is just a general diagram for other projects. So, but it is an area that could be, that has a lot of potential, but it is quite early. So I would say worth having a look at. And I know Giza, that's been around for a while, and they've started to collaborate with other people and started to integrate some established standards within Giza to help people who've come from a machine learning background, help them to get their tools and the results, get that into a format that can be then used with zero knowledge. So yeah, let me know if you're interested in that area any further. Okay, let me just have a quick drink of water. So let's have a look at StarkNet generally, because if you're going to be building on StarkNet, you really need to understand what it is doing, what its strengths and weaknesses are, and also have an idea of the ecosystem. So there is a link. Let me just check that one. There's a link there to mind map. So lots of details about that and features about it. Where you can investigate it some more. But understand where it came from. We had Ethereum, that's a layer one. There was concern about scalability. People started to think of ways to solve scalability. A very popular way or very feasible way to do that is the idea of a roll-up. And one type of roll-up is the ZK roll-up. And this is what StarkNet is. It's a layer two, so it's an existing, or it is a blockchain in its own right. You can have applications running on StarkNet, but StarkNet is effectively taking the execution away from Ethereum and doing that on StarkNet. But then it's relying on Ethereum for security, because what it does is it creates these zero knowledge proofs of the correctness of the transactions being processed, and it posts those proofs to Ethereum. And so people on Ethereum can check them. And because of the security on Ethereum, you can be sure that once it's on Ethereum, that data can't be tampered with. So it's a way of sort of stamping the details of what StarkNet is doing on Ethereum and making sure that can't be changed. But because we have this execution layer away from Ethereum, this means that we can optimize our layer 2 for execution, and it means that we can, our execution can be faster. It means we can have lower fees. So there's all sorts of optimizations going on, and because of this, a large ecosystem has built up. And if you look at Starknet compared to other layer 2s, I think Starknet, was quite early to the game. And so they've managed to build up a large ecosystem quite quickly. And so this diagram is probably a little bit old now, but it gives you an idea just of the wealth of projects that are out there, that exist. And so again, when you're thinking about what to do in your hackathon, have a look through what is there, and see if you can take some things from some of these existing projects. Or maybe it's just going to be, having a look at the tooling as well and making the most of that. But it's a good idea to be aware of what is out there in the ecosystem. Okay. And there's further links to that. All right, so let's go through and talk about how Cairo and Starknet work generally, because you need to be thinking about this, because if you're writing your contracts, this is where they're going to be running. So you need to understand the context of that. So this is a very simplified diagram of the architecture of Starknet. So we have transactions coming in, so they would be from some DApp providing the transactions. Some front end is creating these transactions and submitting these. These go to a node, or particularly they're sent to what is called a sequencer. Now there is at the moment, we have a centralized sequencer on Starknet, but this is going to change. But there are reasons why it was a good idea to have a centralized sequencer initially. And yeah, we probably don't need to concern ourselves with that too much. But the sequencer really is in control, is controlling everything. So the sequencer takes the transactions. It sends those transactions off to be executed. So it will send them to the Cairo VM, which is going to be the virtual machine that is actually running your Cairo code. Now we are interested, or we're involved with zero knowledge proofs, and the proof that we want to create is a proof that this transaction was executed correctly. So once that transaction has gone to be executed, what we get back is what is called an execution trace. So this is a very detailed listing of steps of the execution, and that is used, that is sent to the prover, the shared prover called Sharp, in order to create a zero knowledge proof. And this is the detail that Ethereum wants. It wants to know that this transaction has been executed correctly on the layer 2. There is also there's extra things happening. We do have bundling together of transactions and aggregations of proofs, etc. But the result, the end of that, is that the proof of a number of transactions gets sent to Ethereum, the layer 1, to a verifier contract, which is able to verify a zero knowledge proof. And that shows that our layer 2 Starknet is working correctly. And then the fact that has happened can also go to other contracts and other parts of Ethereum. We also get details of the state difference. So what this is that every block on Starknet has a number of transactions that are involved in the state transition for that block. And so it is those transactions that we are proving, and we send details of those transactions over to Ethereum so that people can see the data that was involved. What this means also for the layer 2, for Starknet, is that the nodes in Starknet can also look at Ethereum and can check the correctness of the execution on the layer 2. Okay, but the reason we need to know this is that when you're thinking about your contracts executing, that's where they're executing. The transaction is being picked up by the sequencer, sent off to the Cairo virtual machine. That is executing your transaction, executing your code, and then a trace of that, a very detailed step-by-step output of that transaction is being then sent off to the prover. Okay. The question about the full node. So there are two parts to that. So there can be part of that can come from the sequencer, but it can also get details from the layer one as well. So yeah, it's this the full node on the layer two has sort of extra options compared to a full node on layer one. All right. So these components, yeah, I've just really said about those. I should say as well that this is a simplified diagram. There is also the possibility of other messaging between Ethereum, the layer one, and the layer two. That is also possible. But that's as you can see here. But we haven't got that on the diagram. All right. So, talking about the language now, um, when you have your Cairo code and you compile this, the way that Cairo works has changed quite fundamentally. So, Cairo 0 worked in a certain way, and it changed very drastically to Cairo 1. One way that it changed was this was an intermediate representation, and this was important because we want to be able to know that a transaction executed correctly. And we want to be able to prove that. Now, when I say executed correctly, that could mean that that transaction fails. For example, if that transaction involves transfer of funds, but the account that is coming from doesn't have enough funds, then that transaction will fail, it will revert. But we still want a proof that that has been done correctly, that the way we checked that and the way we executed that and the way that we know that the transaction failed, that has all been done correctly. And this is what this new representation, Sierra, allows us to do, amongst other things as well. So what we have now is when we have our contracts, is it compiles to Sierra first of all, and then to assembly, and then a proof can be created from this. Okay. As you can see there as well. Chasm is the assembly for Cairo. Okay, I won't go through the roadmap really. You can have a look at that, but this is, excuse me, some details. Just one thing I would say, which I haven't really spoken about, but which could be interesting, is Madara. So this is a sequencer. So I spoke about the sequencer in StarkNet. What people have also thought about, well, they thought about layer twos and said, well, layer twos give us all these advantages because we're taking execution away from the layer one, and we're doing that on the layer two. We're bundling transactions together and sending them to the layer one. So why don't we just repeat this process? Why don't we create a layer three where we take some transactions and execute them on a layer three, bundle those together and send those to a layer two as one transaction. And then that one transaction is part of the transactions that then get bundled to the layer one. And this became known as fractal scaling. And people thought you could have layer three and layer four, etc., etc. Now, I won't go into the pros and cons of all that, but people are starting to build layer threes, and one way to do that is by using Madara. So if you have a look at that project, it shows you how to spin up a layer three. And the reason you might want to do this is that what this allows you to do is to be very specific about how that particular chain works. So you can optimize that either for a particular type of application. So maybe you would create a layer three that was optimized for playing games, and maybe you would change the block time and the transaction fees, etc., so that games were really, would work very well with it. So it could be you would optimize it that way, or you could be even more specific and optimize it for a particular application and spin up one chain for one application. And this is what are known as app chains, and they are becoming people are starting to take interest in this general idea. So I just wanted to mention that because Madara is a way that you can do that for StarkNet. You can spin up an L3 relatively easily with that. Okay. Um, Cairo itself has changed, as we'll come on to. It's the change from version 0 to 1 was very large. 1 to 2 is a smaller change, but there are changes. There's some articles there if you want to read more about them, particularly about the syntax. But it has become, I think, more standardized. It's more similar to Rust in some ways. It's starting to sort of become, yeah, more standardized, like, yeah, sort of embedded in, I think. Okay. And there's some resources there generally about Cairo. Okay, so I'll move on to development tools. So there are a few tools around, and some of these have changed quite a bit, and we've certainly seen quite a lot of improvement, I think, in the last year. As we moved to Cairo 1, we got some new tools. I think the whole area has benefited from this. It's much easier to develop now on Cairo than it used to be. And so some that I just want to highlight, and I was hoping that I would provide you with enough details here that you can get these things up and running, because then, you will be prepared for when you're building your project. But the first one here, Scarb. So this is a build tool. It is really similar to Cargo, that kind of tool chain that we have in Rust. The second one, Starkly, is a way of interacting with StarkNet, and then StarkNet Foundry is really built upon the ideas from Foundry, the project for Ethereum, which became very popular because of its performance. It allowed you to test very quickly. It has some very useful tools, and so this is they've taken this and then tried to produce a version for StarkNet that will allow you to test. But the first one anyway, Scarb. There's details here of how to install it. Please, if you haven't done this, please try these out, and then you can let me know if you have problems. You can put a note into Slido, something like that, and we can see if we can help you with that. One way to help sort of to install it is via ASDF, which is a kind of a general virtual version manager tool. So you can do that. It allows you to move between versions quite easily. So there's details of how to do that there. Or you can if you go to the other instructions, you can do it more directly. But once you've installed it, do check it with, have a look at the version. It'll tell you its own version, the version of Cairo that it has, and Sierra as well. So yeah, you'll get that. Okay, so make sure you've got that up and running. If you're using an IDE, then it may well be worth looking at some of the plugins that are available for that. So there are plugins in VS Code for Cairo, so they can help you. So if you're developing, if you're using VS Code, then it's worthwhile getting those to help you with your syntax highlighting, etc. But there's some links there if you want to try those out. Okay. Starkly, this is a tool that you can use to interact with the blockchain and get your contracts deployed. So there's details to install it given there, and again, just you should be able to see the version. And there's also a good book about it linked there, and an article. Just check that link, make sure that's yeah. That's relatively recent. Yeah, so there's an article about it also. Now, what you need to do if when you're when you're interacting with the blockchain. So say you're going to be deploying things to the test net, then you need to set up some accounts, and you can use Starkly for this. So these are the commands that you need to do. But I can show you more of these later as well, when I go through an example of deploying a contract. Okay. Starknet Foundry, yeah, you need to you need Rust, you need Scarb. There's some links to it there, and as you can see, um, yeah, you can install it like that, and you should get, if it's installed properly, you should be able to get the versions as shown there, and um, the tools it gives you. So there's Forge, which is you can use for testing, and then Cast, which is allows you to interact with the blockchains as well. So it's kind of an alternative to Starkly, I guess. But they're using the same names as the Ethereum tool used here. Okay. So well worth getting all of these things installed and set up. And as I said earlier, when I was talking generally about hackathon tips, make sure when you get your team set up that everybody is set up and has a common tool chain, and you're using the same dev environment. Let me make that a bit bigger. There we go. Okay. Another tool that you may find useful is Katana. And particularly, let me just check. Yeah, so particularly this is useful. Well, we'll see it when we look at game developers using Dojo as well. But it allows you to spin up a local node, just to help you with local development. So um, it's the other way to do that is by the Starknet DevNet as well. One of the sort of common workflows that you will use, I suppose, is when you're writing your code, is that you'll start off and you will do you'll start off maybe some unit tests, and then you'll want to get your contracts deployed. Now, it may be more efficient to do that to a local node by using something like Katana. And then perhaps you would want then to deploy them to a larger network, such as the Gurley network, something like that, where you can effectively then interact with other projects, or just have a larger network to interact with. So that's the way your testing tends to go. You'll start off sort of locally and then expand it. So Katana or Starknet DevNet is a way to do that. And yeah, these are details of how to start it up, and it provides you with some accounts. Um, yeah, the pre-funded. There's also the Starknet DevNet details there that you can use, and details about that, and you can use Docker to get that up and running. Okay, but we'll come on to that really more in the next workshop, where we'll look in more detail at testing of contracts and programs. Okay. So let's take a look at Cairo. I was kind of assuming that people would already know this, but I think maybe some people don't know Cairo so much, so we could spend a little bit more time on it. But anyway, this initial meme is from Cairo 0, because it was a very difficult language to get to grips with. It had a number of quirks, I suppose you could say. There were a number of things that you had to know about it that were a little bit awkward, made development cumbersome and non-intuitive. Thankfully, when they changed to Cairo 1, they really focused on the developer experience and tried to make it much, much better. And so it's certainly much easier to work with now. And if you are familiar with Rust, it should seem quite familiar, the way that you write it. And development generally is quite straightforward, I would say. And so there is a new meme now for Cairo 1. But because old Cairo 0 code will need to get upgraded. So that's what this one is about. Okay. But it's Cairo is a programming language. It's a Turing complete language. The important thing about it, the reason we have to have a different language is because it is used for zero knowledge proofs. And in fact, it is a language that is provable. We can create a proof of the correctness of the execution of this language. So it is a very customized language. And that's, it is very different from the general purpose languages that you will have seen before. It has this idea of what is called a read-only non-deterministic memory model. Now, fortunately, in the latest version of Cairo, we don't have to think about this too much, but you may get references to it. So just be aware that that is what is happening behind the scenes. But a lot of that is just abstracted away in the way that Cairo works now. It is possible to write programs which are you can create these. They can be you can create proofs of these, but they're not really tied to the blockchain as such. But what we're really concerned with are Cairo contracts, which exist within the Starknet chain, and the part of the Starknet or they have the Starknet OS providing their context. And a very good resource overall is the Cairo book. So do have a look at that when you're learning the language. It is very good. Okay, so let's have a look at some basics about Cairo. So it's it's a provable language. But it's still a high-level language. It looks like Rust. Its syntax is very like Rust, and then it compiles down to other representations and into assembly. Now, one thing you find when you look at languages that have been written for zero-knowledge proving systems is that they are often restricted in some ways, and this is because they need to be provable. You need to be able to create a zero knowledge proof from them. And zero knowledge proofs depend upon a certain type of mathematics. And this really can intrude into the language that you're using to write your contracts. And certainly Cairo or Starkware have made an effort to reduce that intrusion and try to make the language as much as like general purpose languages as possible. But where you tend to see it in particular are things like the data types that are available. And Cairo, well, it is statically typed for a start, so you have to be aware of the data types. The compiler does need to be able to work out the type of a variable. And all of the data types really are built upon what are called felts, which stands for field elements. And these are potentially very large numbers. They are 252-bit numbers, or you can see there the exact way you can work that out. But yeah, it's a very large number, but they exist, and the way they work, they are integers and they work with modular arithmetic. And because of that, this means that not all of the operations that you may be familiar with in other languages will work in the same way in Cairo. So some things are reasonably straightforward, addition and multiplication, although you do have to be aware that this is modulo a large number. So you can wrap around. If you go past this large number, then you will start again at 0. But then division can work quite differently. And so there are sort of the everyday kind of division you're used to may not work in the way you expect. So there are ways you can get around that. But just to be aware of that. And this, as I say, this tends to intrude upon the data types in particular, these sort of odd features that you have to put up with. But anyway, our numeric types, our integers, are based on this felt type, this felt 252, but you can have smaller data types than those, as you can see here. So, well, you can go up to, yeah, U128. Now, you have the U256. Now, the reason you would want this is because of you want compatibility with Ethereum. Ethereum has a 256-bit data type, and so it may well be that you want to be able to handle that number of bits in your contracts. But that is larger than our 252-bit felt that we have available. And so the way we get around that is we split it up. So when we talk about a 256-bit data type in StarkNet. What we've actually done is split it into two parts by using a struct into a low and a high part. And then there are operations that will allow you to handle this as if it was just a kind of a native data type, and will adjust the high and the low parts for you. Okay. If you want more details, there's a link to that there. Okay. There are lots of yeah. You get the usual operators. I've given you a link there if you want to look through them. But yeah, you probably don't need to straight away. Booleans are also available, but they are larger than they need be. Strings. We are not native. They have this idea of a short string, a literal. What actually happens is you take this literal and you turn it into a numeric value into a felt. Okay. Now, to convert between different data types, you can use the try into and the into methods. So if you want to cast between data types, that can be possible, but you just need to be aware of the sizes that you're using. So in some directions, it's going to be straightforward because you're going from a smaller size to a larger size. But otherwise, there may be problems when you go to a larger to smaller. So, but there's lots of examples there for you to look at. Okay. So Cairo is the syntax is based upon Rust. There's lots of similarities between Cairo and Rust, but there are some differences. So Cairo, in some ways, is more restricted. One of those ways is the fact that we only have one type of loop, as you can see here, the loop keyword. I mean, obviously in Rust, you have many more possibilities. We are more restricted in what we can do with Cairo. In terms of collections, we have dictionaries, and we can use those. I think I've got some examples later on of ways that we can sort of use these, build these to provide us with other useful structures as well. Now, they do have some assumptions involved with them. So here you can see that the standard one we have available, this Felt 252 dictionary, what this allows, you can parameterize this on the value, or the data type of the value that you want in your dictionary. So, excuse me. If you think your dictionary is composed of key value pairs, then what we're allowed to change is the data type, or when we're creating one of these dictionaries, we can change the data type of the value within this key value pair. But the key part is going to be a felt 252 data type. Now, as you can see here, what we're doing when we're inserting something into the dictionary, so we're doing this with string literals, but they get converted then into the felt, so into a number, felt 252, and then that forms the key for the dictionary. So that is how we're able to do that. So you can see an example here of this dictionary. So we've got our dictionary called balances. It's has a U64 as the value data type, and you can see here inserting some values. Now, one useful thing that you don't get in Rust is this thing called a span. And what this allows you to do is to snapshot an array. So we want this because we often want to be able to get have multiple access to some data structure such as an array, and so a span allows us to do that. If we're just going to want to read the array, we don't want to modify it. So it yeah, we use that. This borrowing issues, I'll talk a little bit more about in a moment when I look at ownership. But it's the span is just a read-only snapshot of an array that can be useful for you. All right. Um, and to do that from an array, you just call the span method, and it will do that for you. Okay. All right. Now, as I said, you can actually put together some data types and in useful ways. So, what we often want to be able, or what we often want, is things like a dynamic array. I mean, this is very common in other languages, but it can be more difficult to achieve. And it's certain, I mean, it's not in Rust, we don't have dynamic arrays. They are fixed size, and we have to have the vector collection to allow us to sort of similar functionality. And similarly in Cairo, we can use dictionaries to then build up things that give us something like a dynamic array or a stack. And I've got a link there to the Cairo book, I think that is. Just check. Yeah, which shows you how to do that. So if you need that type of functionality, then have a look at that. That will help you. So let me just close some of these tabs now that I've used them. Okay. All right. Now, ownership. So this is an area of Rust, and if you haven't come across, if you're new to Rust and you haven't come across this, I would recommend having a look at this because it's one of the areas of Rust that is quite different to other programming languages, and it's often quite hard to get your head around when you first encounter it. So it's worth spending a little bit of time. The reason we have this concept in Rust is for memory safety and to allow concurrency to happen easily. In Cairo, it's kind of similar, but it's more we kind of already have that idea anyway because this immutable memory model. But it's a way that we can get at that or provide that functionality from the language, and but it's a little bit more flexible, I would say, than you see in Rust. Um, but we have this idea of the values in Cairo that they must be used and they can only be used once. So they can either be destroyed or moved. And this concept is a very interesting one because it is also the basis of the move language. And this concept is something that seems to fit quite nicely with blockchains because we often in blockchains work with the idea of assets. And whereas in programming languages, we're used to the ideas of variables or values just disappearing effectively or just being garbage collected or lost in some way. In blockchains, we don't really want that. We're more concerned about assets. And so we do have this idea that we have restrictions about things that in our programs that we've created and what can happen with them. And so in Cairo, we have this idea of things being destroyed or moved, but we have to be quite a bit more explicit about it. Now, moving works in the same way that you may have come across this within Rust, in that the ownership of something is being transferred. And so, for example, if you pass something into a function, so you something is a parameter to a function, and then the variable, the parameter variable within that function then takes ownership of that value. And that then, so what you're doing is you're moving ownership into that function. So that is a way that can be done in Cairo also. or with, as I say, the destruction could happen because a variable goes out of scope, or you can destructure structs, so you can take the items out of a struct, or you can use a destruct keyword as well. Um, so values themselves are immutable, and this ties in with the idea of the memory model and the fact that that is immutable. But variables are mutable or can be mutable. And so this is really a difference that we have with Rust, where we're more concerned, the ownership is more around variables than values. So we have to think then about variables having an owner, there only being one owner, and then that going out of scope. Um, so, for example, this is an example from the Cairo book. If we have the variable s, that has a certain scope given by the brackets. Once that scope is over, then we can't use that variable s again. And with an array, you see this example here. This would not compile because we've created the array, and then we've um, we've used this in two ways because we've tried to move the ownership of that twice, which we can't do. Um, uh, Sorry, in this one with the foo function, we tried to move the ownership when we pass it into the foo function here, this array, which we can't do. The way to get around that is to allow, or in general, is to use something like a copy trait, which allows us to make copies of an item. So in this example here, we've created a struct and we've given this the copy trait, which allows us to use it multiple times. So you can see here in this main function, we have the P1 is our point, which is from our struct here, and we create that giving X and Y values, and then we can pass that into the foo function, and we can do that twice because that is being copied, and so the compiler knows how to do that correctly. Okay. All right, how we're doing? Okay, I think we've got enough time. So let's move. That was a very quick overview of the Cairo language. Do let me know if you need more details on that, because I was working from the assumption that people would have some knowledge of this already, but we can go into more details. Also, do be aware that there will be further sessions about the Cairo language as well, but I can certainly provide more details if you would like that. So let me know. Let me just quickly have a look at the poll. Okay. All right. For those people, because I see there are a number of participants, perhaps some of them joined a little bit later. So I gave a link at the top of these notes to Slido, where we have a poll asking about the tracks that people are interested in and whether they want to know more about the projects. So please do fill in that poll and let me know which projects you're interested in, because we can look at those in a little bit more detail in the further workshops. Okay. All right, so let's move on then and look at Cairo contracts. So we have our Cairo language, but now we're going to look at how we can use that language in the context of StarkNet. And so what this allows is it allows our code to have some state. So StarkNet, the StarkNet operating system itself, gives us context, which allows us to, which effectively gives us storage, allows us to store state within our contracts. And that's typically what you use contracts for when you have a transaction. Typically, what that transaction will do is to change the state of the blockchain in some way. Typically, the state of a contract. So that's generally what we are wanting to do. So, what does a contract look like? So there are a number of things you need to do. So we have these annotations that we need to add to our code to 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 get the compiler to understand what we want, how it's going to be used. So you can see the first one here. This is we use this to declare the contract, and so we put that above the module declaration, and then our code can go within that. Now, the excuse me, one change that we've had more recently is the idea of interfaces, or the way that this has been done has changed. What we use this for is really the same way that we use interfaces for in other languages, is to provide a description or a skeleton really of how we can interact with our contract and the entry points to our contract. So to do this, we use this interface, as you can see here, and we provide a trait for that of some named in some way, which will be parameterized with contract state. And then within that, where we've got code here, you would then put in the different functions that this contract is going to provide. The components I'll cover at a later time. They're a bit more of an advanced feature, so I'll talk about those later. We'll come on to the more common things. So storage. This is where we have the state within our contract, where we can actually store data. So we have an area, we have a struct where we're going to store our data, and then we annotate that with storage to show that that's the state of our contract. We have a constructor, so this is code that's going to be run just once when our contract is deployed to do some initialization, for example, and that will take details of the state of the contract. I'll come back to this external. We've got more details of that. And then we also may have events within our contract. Events are very useful. They show what is happening within our contract when it is being called. You really should have an event for all the changes of state happening within your contract. It's good practice to do that. It means that, well, third-party applications can react to what your contract is doing. It can be used for monitoring as well. So yeah, I would have more events rather than fewer. We may have other traits. I'll come back to that. And you'll see read and write functions as well. So we'll go through, it's best to see some examples for those. So we'll come on to those. But just to say that the way the way Cairo has developed has changed more recently by using traits and implementations. So this has been done to try to make things more readable and more structured, I think. And so you'll start to see, if you've been using previous things, then you'll see changes with this StarkNet prefix. Excuse me. But yeah, so now you would see things like this, whereas before you had that just the ABI. Okay. And one of the bigger things, I guess, is the storage is annotated there. Sorry, it has that attribute, the storage attribute, as you can see there. So this, for example, is showing some state. We have a numeric value being held as a total, and then we have this dispatcher. So what this effectively is doing is holding it's like holding an address really for another contract. So if we're wanting to interact with another contract, it's a way of keeping details of that within our storage. Um, yeah, and so the way that this is being done generally is using generics such as the T contract state and self to show the contract itself, to be able to refer to the contract. And this is I guess just making things more like Rust and making the language more standardized and safer generally. Um, but yeah, you can see it allows us then uh, uh, to or gives us more flexibility because we can parameterize the state when we're talking about this. And as you can see here, by using this T contract state when we're showing our interface here. Okay. Um, So this would give us, so this is, for example, is for a particular contract. We've got this math contract, and we're saying that we've got some functions here. So we're using this as the interface for this contract to show the functions that are available and the signatures of those. So the one here we're doing for the get total. This is going to obviously it needs the contract state for that function, and it's going to return us a U128 because in this example that's the total that we had, and then we have these other addition and subtractions, which again are taking the contract state, but we're passing in amounts to update the state there. Um, okay. So we used to have this view attribute, but that's been removed now. And what the way that or the reason for this is that we have this concept now of a snapshot, which is shown by the and here. Oh, sorry, the at symbol here, when we're providing state. So what this means is that when when we're getting this state, we're getting a snapshot of the current state. So this get total here, you would previously have seen that as a view function because it is just bringing back a particular value, bringing back a particular number here. But we don't need to do that. It's implicit because we're using a snapshot for the contract state. And then the kind of the opposite to that, where we used to have this external attribute, we now show that something allows modification by the ref argument. So you could see in our interface here that for these functions we have this ref keyword here, which is showing that we're actually going to be updating the state. So uh, it's in some ways it's more explicit. I think in the previous way it was done, it was a little bit more ambiguous what was happening, although perhaps that was more readable. But once you understand the way that this is being specified, then it becomes obvious what types of functions these are. Okay. Okay, so we've shown that there. This is I'll skip over this. Perhaps we don't need to go into that in too much detail. It's just allowing for some flexibility in the way that things are compiled there. It means we could have different implementations with the same name. So yeah, so you can see here you could have two versions where one version was returning a U128 and the other version was returning a U256. So it's a way to do that. But I think it's perhaps we'll come back to that later. Um, Events, there have been changes with those as well. Um, so we have this event attribute. It is derived from the StarkNet event, so we have to say that, and then we can give details of uh, the the particular events, such as additional or subtraction there. And so those are where we list out our events, and then we can give the particular details for each event, um, shown here in a struct, where you supply or you give information about the data type that is going to be within the event, as you can see here. And events work in the sort of standard way in that we emit them, as you can see here. Because there is this self is being used, that comes from the contract state, and so because yeah, that needs to be provided. It is part of the blockchain state, and so we do that emit, and then the particular event, and then we can provide the parameters to that event, as you can see there. Okay, so all right, so I can just quickly go through an example now of setting up a project. Now let me have a look. I went through this earlier, so to check it out. But I've actually gone through it, so I'm sort of I can show you some code, but it's not. I didn't want to have to go through typing all of this in. Um, but yeah, the easiest way to do this initially is to use Scarp. So you have to go back. Yeah, go back. Make sure you've got that installed. I showed you there's a couple of ways to do that. You could use ASDF or you can just install it directly. But either way should work quite readily. And then to Scarb really is very similar to Cargo if you're familiar with Rust. So you can do Scarb and then new and then a project name and it will create a project for you. Or you can also create a directory, go into the directory and then do Scarb in it, and that will do the same thing. So you've got a couple of ways to do that. But once it'll create you a default project, which looks like this. So I can show you in code. Now, I do apologize. So I've got what this is. I've got a code server providing me or providing this environment, and it doesn't do the uh, um, it hasn't done the integrations very well. So I'm not getting yeah, I'm not getting syntax highlighting. So I do apologize for that. But it was easy to do this than spin up VS Code. But anyway, this is an example of if you create a Hello World project, you'll get something like this. Actually, you won't get that exactly because I've changed it, but you will get this format, yeah, just general format. So you'll have a source directory. You have a TOML file. So this is the configuration file for you. Yeah, so you should see that. So that's the first thing, and what it would include for you initially in the source directory is this is a libcairo file, which I've changed because I want to add to that, but we'll come on to that. Now, if we're if we're going to be creating contracts, we need to add some we need to add to our TOML file to show that that's what we're going to do. So you can see here, I've added this line here, it's line 11, to show that's the target. So when we're compiling, we're building contracts rather than anything else. This I've also got this Sierra equals true, so this is the intermediate representation. I think this is the default anyway, so you probably don't need that. But anyway, that's there. You can add other options as well and turn various things on and off under that particular target. Okay, so that's that. The dependency. Actually, I've updated this from this version of StarkNet. So I've gone to 2.2. So yeah, I would take the later version actually. Um, um, so yeah, as you can see here. So if you add all that in, what your TOML file should end up looking like is something like this, or as you can see, like that. Um, and yeah, you can add obviously you can add other dependencies as you need them. That's what the TOML file is there. That's what Scarb is all about, being your package manager. Okay. There's a good cheat sheet available to you if you want to find out what Scarb can do. So yeah, this tells you all of the details about that. So uh, yeah, you can have a look at that. All right. Now, I'll go through a simple example, which is what I've done in that exam in that code, where we've got a file called contract. And what I've done is I've got this is our contract that we're writing. So a very simple contract. What let's just have a look at it. I don't know if I can get the uh, whoops, I didn't want to do that. Sorry, it's difficult to get my no. I don't think I can easily. Oh, can I? Maybe I can change this. If I say this is Rust, okay, that's a little bit better. Um, so this is our contract. Sorry, it has gone a little bit odd, but anyway, so this really should, this is what I've been talking about, uh, the anatomy of a contract. So it should look familiar. Um, we've got this interface here showing the functions that we're interested in, dependent on some contract state. So these are both we both of these functions are going to change state. So no, sorry, no. The top function is going to change the state, so that's got the ref. The bottom function, get balance, is a view function, so that's got the snapshot for our contract state. And then the contract itself, you can see here the area for storage. So we've got our storage, it's just one item, the balance here, which is type felt 252. And then we have the actual implementation then of this interface. So the implementing these functions. So we've got the get balance function at the bottom here, as you can see with the snapshot. And so what this is doing is from the variable within our storage, it's doing read. So this is the way that we actually get the item from that. And then for when we're writing to the storage, as you can see here on starting on line 16, increase balance function. This isn't a snapshot, this is a ref. And so what we do on line 18 then is from the balance we write, and we write the old balance, so with the read of the balance plus the amount that we've passed into this function. So quite straightforward, I think. There, so that's our contract. So I've put that in, and then in my lib, I've just specified that that's there, that we've got that module. Okay, so that was the next step. which is all detailed here. I've gone through that. I think it's easier though to see it in VS Code rather than on the page. Also, I've put the code in a gist as well, so you can copy that out if you want to. So once you've got your code here, what you can do is then build it. So to do that, you run scarb build, and what that should do is then build the targets, and uh, you'll get this target folder, and we've got dev targets here. So this is the compilation from our contract. So this is what happened when I compiled it earlier. So these artifacts are sort of saying the general details, and this has got all of the bytecode, etc., from our contract. Okay, so far so reasonably straightforward. Now, yeah, the one we're really interested in is this the contract class file, which was yeah, whoops, which was this one. So once you've got your contract, I mean, I know I've skipped quite a step here because obviously you would be writing your contract and you'll be testing it some more, but we'll come on to that later. I wanted to get more of the environment set up for you here. So this is more about using Scarb and Starkly for deploying our contract. So um, what we need to do is we need to get, first of all, you need the account set up. So you need to get your account set up on the particular blockchain. So I showed you these uh, these uh, these statements before, but this will allow you to set up your account. So what this is doing is to create a new key store, which you can then use. So when it asks for a key store later on, this is the one that will get used. And you can see here, I did that, and it created the key store for me here, and a particular account there. So yeah, that's what this was doing. Now that gives you an address, a public key, an address on the blockchain. So what I was doing is I was compiling this and sending it to the Gurley blockchain. So what I did was I went to the faucet, which yeah, this one, and asked for some test ETH there. So that's the next thing so once you've got your account set up, then you can fund it from there, as you can see. Uh, okay. Oops. Sorry, let me just look. So there's a question about sorry. There's a question about this code. So what I did, so this is just Brave browser. Well, what I did was I've got a code server running, which effectively, yeah, acts as a server for VS Code, and then it provides a front end. So I could just go to I can just browse to that, and it uh, I can just browse to that, and it provides me with VS Code. So it's similar to what you get if you go to things like on GitHub, like workspaces. It's similar to that thing. Um, uh, yeah, this is recorded, I believe. Yeah. So let me just go to Slido a second. Okay, it's not going to, doesn't want to work. All right. But anyway, yeah, that's what this is showing here. But I mean, you can just do use ordinary VS Code for that. So that's getting the test funds. And then what you need to do is slightly different to what you have on other blockchains in that, first of all, you declare your contract because what we have this concept of a class or a contract, sorry, a contract class, which is really the the general details of your contract. But then from that, you could have multiple instances of that contract. So first of all, we need to declare the class and then get that onto the blockchain. So that is what this particular item does here. So if you run that, that should work. I did have some problems with this, so you may want to check. I think maybe getting rid of the network might help, but let me know anyway if you have problems. But anyway, once you've declared that, what it does is it gives you a hash, a kind of, so that's saying this is the fingerprint of this class, and it sends you back a hash. And when you have that hash, then you can deploy that and get some actual contracts that you can interact with. And so for that, you use Starkly deploy, and then you give the hash that came from the previous step. You need, with all of this, with all these deployment of the declares, you need to show which account you're using. So you need to give details of the key store. But once you've done that, then that's it. That will then deploy your contract onto the test network. So please try that out. You should be able to do that. That's what I did with this, and it did deploy it. I think, yeah, eventually I got this. Here's my, which one was this? I don't know if this was the declare or the deploy. A second, we'll have a look. Oh, this was the deploy. So on Voyager here, you can see this is the transaction where I deployed that contract, and a few hours ago, yeah, it looks like it's still not accepted on layer one, but I guess it's just a test network. So, but you can see anyway, that's once you've done that, you'll get the transaction hash, so you can check on it, and that's it. You're successfully deployed. Okay. Open Zeppelin contracts, I'll come back to those because we can do that next time. But I think, yeah, what I would say is try out this process. You've got an example contract, so that you should be able to do that. But try out the process of using SCARB, etc., to do a declare and a deploy onto a test network, so you can make sure that your environment is all set up. Okay, so I'm going to finish there. Let me just quickly scoot to the top of my file. Uh, so I'll finish there. That's the first workshop done with. What we'll do in the next workshop, as long as so as well as answering any questions that people have, I'll look then at more details about Cairo. We'll also look at testing in more detail, the sorts of things that we can do. If you do have questions, please put them onto Slido. There's details of that. The link to that is given in these notes, and these notes themselves are at this address. I'll just put that into chat once again. There you go. So that should give you everything that you need. So thank you, everyone. I'll stop sharing now. Thank you, everyone, for joining. I look forward to seeing you at the second session. Thanks, everyone, and I'll see you soon. Thanks.